Okay. I just am going to assume this works. I've done it before. I hope when I record that it shows like the Elmo. We'll see. Okay. What? Oh man, what a start to 2021. Worst year ever. It'll be very hard. Okay. See, now I feel bad that I started recording because now the kids that have to watch the e-learning have to. I cut my vid. What does that even mean? Huh? I'll edit it for you. Okay. Big explosions and transitions. Meh. Dramatic effects. I wonder if when you go to schedule, you will.
Last year we just got told. Last year it was like
you won't. So this year's different. You will go in and pick and schedule yourself, but then I think you'll sit. Then I think you'll sit with your counselor after you've done it, so that they can kind of go over it with you. They used to not have you do that. They used to just sit with you automatically. And I think that took a very long time. So now they have students do it. And then the meetings don't take as long. It's like, okay, that looks good. You're set. But then that way they can fix some people. I think at that point you see your recommendations.
Okay. Last year I got up there and she was like, what class are you taking? And she said, you should take that one.
Quite honestly, the way I say it when I make my recommendations, if you got a B or above, like an 84 or higher, I would say you're fine to take honors pre-cal. It's usually if you got below that. It's not always. I mean, it's not like that's the deadline. That's what is set in stone. I take a lot of things into consideration. I think this year has been a little easier than past years in terms of we took lessons out, but I think harder because a lot has been on your plate with being at home. So, I don't know. It was tough. It was tougher this year to make recommendations, but I did the best I could. So like I said, I would never tell someone they can't take a class. I've done where I've recommended kids for regular pre-cal, and they have flat out come up to me and said, I want to take honors pre-cal. I think I can take that class. And then I have to sign off on like an authorization paper saying, you were not recommended to do this class. You're taking this class. And then it's kind of like on the student at that point. You went against the recommendation. So, but then they've succeeded. I have a kid in AP Calc this year. I didn't recommend him for honors pre-cal. He took it. He did okay. I mean, it's not like he blew it out of the water, but he worked hard, and he's doing well in Calc. So, it happens. Okay, so this semester, well, I want to do some review. Before we dive into the notes, I published the page, right? It's open now? Yeah. Okay, I want to start with just a little bit of review, okay? So, Joni.
No.
What? You guys don't need to write this. Okay. Solve that equation. 16? Holy cow. You remember a lot. You guys were all worried. Okay. Next one. Brenna.
Oh, no. 5.
Nice. 5. What are you guys so worried about? Just review. Next one. Mason. 4 to the x equals 20. Okay. Huh? Why would I do something like that?
I don't think I'm gonna go out and win. I don't think that one's possible.
Okay, Mr. Money thinks this one's not possible. You guys at home, I want you to try to solve it. You guys in here try to solve it. I want to see who can give me the right answer. Is there an answer?
It's gonna be like a decimal or something. It's gonna be
It's gonna be a weird one.
Why? Because it's a decimal. Does that mean it's stupid?
Because decimals are stupid.
My son's learning decimals right now.
Okay.
Your son's not dumb. Decimals are.
They were doing 2/10, and he knew that was 0.2. And then I said, okay, what's 2/5? And he said 0.2. He thought it was just the top number. So we had some learning to do. I think he gets it now. I need someone to tell me this answer.
Is it 2.114742?
No. But what did you said 2.11 something?
2.11, yeah.
What? No, but how'd you get that number?
Oh, I plugged in decimal.
It's not a bad idea. Anybody get an answer? You guys at home can shout it out too.
No one wants to talk at home.
Well,
That is true.
No, because it's embarrassing.
Why?
I don't know.
It just looks weird talking to an iPad.
Yeah, like I'm scared I'm gonna like mess up my words, and I'll be like.
well, so I'm gonna tell you, they have said like for teachers to get the kids at home more active and engaged. I'm gonna do what I did first semester because it worked for me, but I'm just saying you might have some teachers that do some more stuff.
Oh,
So
my Spanish teacher is like, you need to be wearing actual clothes. You need to be
Well,
sitting up.
yeah, I'm just saying you might see a little bit of change when you're at home this year for some other teachers. Nobody got it?
No,
I don't even know where this is.
Well, what'd you say?
It's 2.6.
Let's start there.
2.5.
Riker said it's 2 point something.
It's not 2.5, I already plugged that into it.
Okay, Riker said 2 point something. First of all, how do you know that?
Because 4 squared is 16.
4 squared is 16.
And 4 cubed is more than 4.
Well, what is it?
I don't know.
64.
64. Okay. So okay, this is important. This is important. We know it's between 2 and 3,
It's
right?
closer to-
and it's closer to 2.
It's less than 4 for the 2.25.
So it's less than 2.25. My point is, you guys are finding out there is an answer, right? Like you're narrowing in on it. We don't know what it is yet. You're guessing and checking. Think of all the equations you guys have solved in your life. I want you to think about that question. How many equations have you guys solved in your life? What? Give me a number.
Like at least 7.
500?
More than 100.
Yeah, more. Okay. How many equations? Think about this. This looks like a very simple equation. It has a 4, it has a 20, and it has an x, just like these other first 2 equations did that you guys solved like that. Out of all the equations you guys have solved, you have never solved an equation for an exponent. Isn't that crazy? You've never done it.
No, I'd like to go back to that.
This whole chapter is about solving equations when you're looking for what the exponent is. In this chapter, we get into this thing called logarithm. You guys heard that word? Logarithm?
I got very close.
If you look at your calculators, the button that says log on it. Okay, we are going to be using that button in this chapter. Here's the downside. Today, I am not going to teach you how to solve this equation.
That's really mean.
I know.
That's really nice.
Yeah.
Thank you.
Would you solve it like this though? Like, is that how you-
No, because you're thinking of if it was like this, then you would take the 4th root of both sides. Here's the deal. You can't take the xth root of both sides. You get nowhere. And that's what a lot of students try to do, but you don't get anywhere. So, but like I said, we are not going to learn today how to solve this equation. We will learn how to solve this equation next class. Okay. All right. We'll learn how to do it. You'll need your calculator to do it. The answer, by the way, is
No.
Okay, I got close.
it's an irrational number. It's actually a number that will go on forever, but it's 2.160964047 da 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 da.
Okay, I got to 1.
I got
I guess it's not right. I got to
2.16. Yeah. So look what happens. So if you would do 4 to the 2.16, let's see what we get. 19.97. So you're pretty close, right? And then round up. So again, we will learn how to solve that, just not yet. Okay, I have one more equation to solve. Mason, I'm going to give you a redeemer. Okay, before we move on to the notes. So the next equation that I want us to solve is 3 to the x equals 3 to the 5th. Mason, I want you to tell me what would x have to be to make that equation true?
Gone out of limb here. 5.
5. What in the world? What's the difference? Here I asked you to solve for an exponent, and everyone was like, well, it's impossible. Here I ask you to solve for an exponent, you tell me the answer right away.
That's because there's an exponent on the other side.
Yeah.
So this leads into today's lesson, okay? Solving for exponents is easy if on both sides of the equal sign, you have the same exact base. If you have the same base on both sides of the equal sign, then that means the exponents would have to be equal to each other to make the equation true, right? So what today's lesson is, we are going to be solving equations for exponents, but all of the bases are going to be the same on both sides, and we're going to be able to set the exponents equal to each other. Where we head in the chapter is, well, what happens if the bases are not the same on both sides? Now what do we do? That's where logs come into play, and that's what the rest of the chapter will be about. But today's lesson is about solving these types of equations, okay? So we're going to be solving what's called exponential equations. An exponential equation is when you have a variable as an exponent. That's an exponential equation. And so we're going to jump to the notes. Let's do this. All right, so I just said our equations today are going to have the same base on both sides, and then we just set the exponents equal to each other. And then I start with example 1, mean old Mr. Giordano, and those bases aren't the same. You just lied to me.
Yeah.
Tell the truth.
I'm a liar. Now, how can you trust me?
You have to stand in the corner.
With a dunce cap. Class dismissed. Okay, so
All right.
here's the thing. We can easily solve exponential equations if the bases on both sides of the equal sign are alike. Because if they are, then we just set the exponents equal and we solve that equation. These bases are not the same. However, we learned something way back in chapter P. It was a long time ago. It's back in August. And so I'm not going to say, how dare you not remember? But back in August, we had to change how numbers looked, but they still meant the same thing, right? Like, how can I write the number 8 so that it means 8, but it looks different? 2 to the third, right? 2 to the third is 8. So what our job today is going to be, if you look at all these first 3 examples, none of them have the same base on both sides of the equation. None of them do. Our job is to figure out, okay, what base can we change the given bases to so that they're the same? I'll give you a tip. You're either going to be changing these bases to like 2s, 3s, 4s, or 5s. Like you're trying to get both bases to be a 2, a 3, a 4, or a 5. That's going to be your thought process. So if I look at this one, I'm like, okay, I can change the number 8. You know what a lot of kids do wrong right off the bat? They'll like divide both sides by 2. When you're dealing with exponents, a lot of the rules of algebra that you've learned, they don't work how you've learned in the past. Like that one equation that I put, 4 to the x equals 20. This one, you can't just divide both sides by 4. You don't know how to solve that one yet. So the rules don't work how they normally do. But we can write the number 8 as 2 cubed. So the left side we leave alone, but the right side, the number 8, we're just going to write 2 to the third instead. It's the same thing. 8 is 2 to the third. And then behind that 3, we just put that exponent that was there next to it in parentheses. A lot of students struggle with changing the base. And so I'm trying to give you the tip. You're going to be changing these to 2s, 3s, 4s, or 5s. Okay. I'll get a lot of students that'll be like, well, how can I change this 2 to make it an 8 instead? You're not going to do that. You can't. You can't make 2 become an 8 by doing something. But you can make an 8 become a 2 by writing it as 2 cubed. So my advice to you, when you change the base, make sure what you changed, like what you wrote, is the same as what you started with. It should be the exact same, just look different. Now that we have the same base on both sides, well, in order for this equation to be true, the exponents would have to be equal. Once you accomplish this goal, now you just set these 2 exponents equal to each other, and we solve the equation. So I'm going to distribute that 3. Now, once I solve this equation, I have the answer. So subtract x, add 3. Your brain wants to say x equals 2, but be careful because you would divide by 8 and x is 1/2. Silly brain. Tricks are for kids. X is 1/2. What time does class end? I forget. Oh, we're in good shape.
Do we have homework?
Yeah, it's a worksheet.
That's weird.
It's like 11 problems. All right. So example 2. So look at example 2. And first thing I noticed, those bases are not the same. And now I'm thinking, okay, I got to change these bases to be a 2, 3, 4, 5. Maybe 6 if I'm feeling gumptious. But that's what's on my head. what can I change a 27 and a 9 into? What base?
33 cubed.
Yeah, 3 cubed and 3 squared. But I start with, I can change them to 3's. Okay, then I think 3 to what? Well, 27 is 3 cubed. And 9 is 3 squared. Remember, we're trying to get the same base on both sides. And I just check myself really quick. I just look and I'm like, okay, is this thing that I wrote the same as what I started with? It is, okay. Is 3 squared the same as what I started with? It is. I've done it right. Now that I got the same base, set the exponents equal. So I like to distribute in this line, saves me a step. So 3x plus 9 is 4x plus 2. X equals 7. Don't say what, like you don't know. 7 is 7.
I thought I was the one who failed Spanish.
All right, the next one.
You failed reading, not listening.
Listen, you have done this, there's no such thing as fail in Spanish. You get like a
You mean
D
pass
and
in
you're like,
Spanish?
good job. Well,
All right, next one. What do we want to change these bases into?
something lost right.
And so this one looks tougher, but in your mind, think 2, 3, 4, 5. Start there.
5.
5. One, yeah. So I have a 25 there. I have a 125. 5 is what I'm going to want to do. I get too many students that they try to change like 1 over 125 to be like base 25 somehow. I'm not going to do that to you. You're going to change these to be a 2, 3, 4, or 5. If you're not doing that, if you're thinking about too big of numbers, you're doing something wrong. So 5. Well, the right side is pretty easy to see. It's 5 squared. What is 1 over 125 the same as?
Negative or 5 to the negative third.
5 to the negative third. Bingo. So this is where our negative exponents might come back into play. And think about why. 125 is 5 cubed. But 1 over 125 is 5 to the negative third. I was going to say negative cubed. I don't think that's a thing. So 1 over 125 is the same as 5 to the negative third power. Now the bases are the same. Set those exponents equal. You guys missed this?
No.
What?
Actually, I did get so bored over break that I started rewriting all of my paper notes on my iPad.
Oh, I thought you were gonna say you started reading the textbook
No,
for.
the textbook went on my floor. It went on my bedroom floor as far away from my bed as it could be.
My textbook did not leave my backpack, so I packed it up.
You're telling me no one pulled out the algebra book and started reading it? You could have learned this already.
My textbook didn't even leave.
Mason, had you done that, you would have known the answer was 2.16.
All right.
I don't know. Honestly, I don't know why Desmos didn't give you the right answer.
I mean, well, that's because I did 4 divided the square root of 20. Like
The
how
4
I
through to
showed
20?
Like how
Oh.
I showed you earlier.
I gotcha.
That's why I didn't.
So you just did it wrong.
Yeah,
I see.
Okay.
I was close though. So.
Well, that's why I asked how you got it, because your answer was so close. I get x equals 2.
Negative. That's my goal for this semester. Learn how to
So-
make numbers work.
So your assignment is a worksheet. We're not done, but your assignment's a worksheet. And I think the first 7 are just ones like this, where you're changing the bases, setting the exponents equal. Okay. Questions on those 3? Like I said, we will next class learn, okay, what if I get one like, because here's the thing, what if I had 2 to the x equals 7, right? There's no way to get the bases on both sides to be the same. Like I can't change 7 to be 2 to some power. So there's got to be a way to solve equations when that can't happen. The ones I'm giving you on these notes and the ones that are on your assignment are designed very nicely to work how I want them to work. But the point is they're not always going to be able to work that way. We'll learn how to solve ones that don't. And like I said, it'll involve your calculator and logarithms. Have you ever wondered what that button was for?
No, because Calvin told me.
Oh, he did?
Yeah. He sat me down when I was in like 2nd grade. He was like, here's algebra.
Oh, that's then you should have known it was
Why don't
2.16.
you have 100% this class?
Yeah, because I'm bad at negative. I don't know negative numbers.
Okay, so the next one. So last semester, we talked about graphs of different shapes. We did lines. We did parabolas. We had a whole day where we like made tables of values and like sketched graphs. We did the absolute value. Anybody remember what the absolute value graph looks like? It's a V shape.
I put all those on my review sheet.
Yeah. Oh, also, the extra credit or the like cheat sheet paper with both sides apparently slipped my mind. So maybe next year be more clear about that. He was not. He said, "Here's a half sheet of paper."
I just used my own half sheet, and if for some reason I was wrong, then I could just say I wasn't there, because that's not a lie.
That's fair.
All right, so the next graph is, we didn't talk about exponential graphs. Have you guys ever heard the phrase, it grows exponentially?
Yeah.
Yeah.
So what does that mean in general? Right, but yes, that's what the graph will look like. But what does it mean to grow exponentially?
It's like, you start from like low, it slowly goes up, and then it's just like,
Yeah, it grows very, very big, very quickly. That's what it means to grow exponentially. And so we're going to graph this, and we're going to use the process that we did first semester. We're going to make a little table of values to see what this graph looks like. And when we make a table, I always like to pick, a couple negatives, 0, and some positives. Now you have full power in what you choose in terms of picking what to plug in for x. And now I'm just going to plug these numbers in. I'm not going to use a calculator. So if I plug -2 in for x, what's 2 to the -2nd? And don't you dare say -4. 1/4. Thank you. 2 to the -2nd power is 1/4. 2 to the -1st power is 1/2. Ooh, here's a good one, Riker. What's 2 to the 0?
No.
1. Anything to the 0 power except 0 is 1.
What's 0 to 0?
Oh, I'm glad you asked. I was just hoping, like, inside when I said that, in my mind, it's really funny how teachers, in my mind, I was like, gosh, I really want them to ask. Because if you didn't, I would have been like, does anybody know why? Like, I would have said it anyway. But
isn't it because like, well, 0 to the 0 power, it's not undefined?
it is undefined.
Okay.
Yeah, and the reason it is, math is so cool.
No, but okay.
I disagree.
Okay, so the reason, like, if I had 2 cubed, that's 8, that's 4, that's 2, that's 1. First of all, the reason anything to the 0 power is 1 is because when you decrease these powers, you're just dividing the right side by the base every time. And so you basically, something that is 0 power means you're dividing that thing by itself. And so if you have 0 to the 0 power, you can't divide by 0. This basically means 0 divided by 0, and that's undefined. You can't do 0 divided by 0. That's why. Okay. See, I was so excited to come back and just do all this stuff. All right, now I'm just going to plot these points. -2, 1/4, and it's just estimation at this point a little bit. -1, 1/2, 0, 1, 1, 2, 2, 4, and then 3, 8. 6, 7, 8. Just have to estimate. Yeah, you can see that shape. Brandon, you said it was like a J shape. It is. And you can see how it grows so quickly. Exponentially, if you will. Notice it levels out at the x-axis, but it will never actually get to the x-axis. Think about how crazy this is. This isn't even part of what the lesson was supposed to be, but think about how crazy this is. I could plug in -100 for x, and it will never become 0. Like 2 to the -100th power is like 0.00000000000000001. It's still above the x-axis. Isn't that nuts? I could plug in negative quadrillion billion bagillion,
That's not a number.
and it would, I'm sure it's not, but it would still be above the x-axis. Like it never gets there. It's almost there right now at -2. Isn't that crazy? Does anybody know what that makes the x-axis? Anybody know? I don't know if you know this word or not, but we get into this word in the next chapter, and that's kind of why I'm thinking about this now. Does anybody know what a line in math is that your graph will never actually get to? I didn't know if you had heard it.
Oh, no.
An asymptote. We get into asymptotes in this semester. Asymptotes are imaginary lines that you don't need to know this for this chapter, but they're imaginary lines that your graph will like get infinitely close to, but never get there. Super cool. Yeah.
This might sound really dumb, but I'm kind of confused on the negative exponent.
No, I'm glad you asked that then. So if I plug -2 in for x, and I had 2 to the negative second power, remember a negative exponent means reciprocal. It means you flip it. So if I flipped this, it would be like 1 over 2 to the positive second, which would be 1/4.
I remember that.
Yeah. Well, I'm glad you asked then. Once we get to second semester, it's not a great thing, but I just kind of assume prior knowledge at that point. So if ever I'm like, oh, you should know this, just stop me and ask. Because if you had that question, I'm sure that there were other people that had that same question. All right, and that's our graph. I just wanted to show you what graphs of exponentials look like. That's it. We're just sketching the graph to show the shape, how it grows so quickly. Let's do the next one. I think there's a couple on your homework that you'll have to make a table and sketch. Oh yeah, the graph. Yeah, we still have some things to learn. Yeah, we got a whole formula to learn on the back.
I don't like that.
Okay, the next one. So again, I'm going to plug in, a couple negatives, positives. It really doesn't matter. There's not a set rule on here, the numbers you should plug in. I'm just plugging in some. And I'm going to do some mental math. If you need to use your calculator, I guess that's fine. So if I plug -2 in for x, -2 is 2. Remember, you have to do 3 squared first. It'd be like 9 times 1/2. So 4.5. Plug -1 in, so you get 3 times 1/2. 1.5. Let's plug 0 in. So Riker, I'm going to give you a redeemer. If I plug 0 in, I would have 1/2 times 3 to the 0. What would we get? It'd be 1/2. Very good. The 3 to the 0 becomes a 1, and then times 1/2. You get 1/2. Plug 1 in. This is when it doesn't get very fun. What'd you say? Was that a math slight, or were you complimenting math?
You said less fun, so I said
Oh. So I plug a 1 in, so I'd have, okay, so this would be 1/2, and then 3 to the negative first is 1/3. So it'd be 1/6. Which really all that means is it's just above the x-axis. That's all that really means right here. I mean, at this point, you should know based on what happened in the first graph, what's going to happen here. It's going to get really close to the x-axis, and it's never going to get there. The point of me showing this one is we're dealing with exponential functions in this chapter. Sometimes those exponential functions grow. Sometimes they decay. So we have exponential growth and we have exponential decay in this example here. Just showing you that when you talk about exponentials, it doesn't always just go up. Okay, things can go down. When you get into, I don't know when you start getting into like radioactive elements and decay. I think in chemistry, you guys talk about decay.
Right now.
Well, then maybe you'll get into logs then right now. I don't know.
Please tell me.
The geometry kids have to learn them in chemistry instead of in math. So it's gonna be soon.
Yeah, I just didn't know.
That's literally one of our vocab words.
Wait, why would you take chemistry honors?
What was the vocab word?
Radioactive decay.
Yeah.
And like half-life.
Yeah. Yep.
So fun. Well, no,
Speak
because
for yourself.
you're not supposed to take honors count if you haven't taken geometry, but kids end up.
Half-Life's a pretty good game.
Yeah.
All right, I never played it. Half-Life, never played it. Okay, last thing.
I know, I think maybe.
So first semester, you guys took a final, and there was an interest formula needed that if you didn't have it on the half sheet, hopefully you remembered it. I don't know if you did or not, but there was a problem where you had to know that formula. And it was all about if your interest compounds a certain number of times in a year, if your interest compounds monthly, if your interest compounds semi-annually or daily, or whatever the case may be. When your interest compounds a certain number of times a year, you have to use this formula here. You have no choice. Now, here's the thing. There is another type of compounding, and it's compounding continuously. What that means is if they say your interest compounds continuously, what do you think about what that means? It's constantly compounding. It's constantly growing. It's never not growing. If your interest compounds monthly, think about what that means. Your interest goes for a month. You have the same amount of money for a month, and then boom, you get interest. Now you have more money. And then a month goes by, and you have the same amount in the bank, and then boom, you get interest. And so every month, the amount of money in the bank goes up. Continuously means it's never not growing. When you see the word compounding continuously, that is a new formula that we have to know. And here's that formula. It's A equals P. So it starts the same. You're getting a final amount. You have a starting amount. That's what P is. Here's the new part. It's times E to the RT power. I get a lot of kids that know it as the PERT formula. You do not get to choose which formula you use. You can't be like, oh, I like the first one. I'm just going to use that every time. The problem dictates which formula you have to use. If you see the word continuously, you have to use the one with PERT. If it says it compounds monthly, daily, semi-annually, whatever the case may be, you have to use the first one. I think on the homework assignment, there's a few at the very end, interest problems where you have to decide which one to use. But if you see the word continuously, you have to use PERT. Now, here is the deal. There is no bank in the world that you walk into with $1,000 and you say, give me the account where my money never stops growing, please. I want the compounding continuously account. It's theoretical. It's not a thing, okay? Then the question comes up like, well, if it's not a thing, then what are you doing? Why are we learning this, right? Well, so what this will lead into, there are things in the real world that grow continuously, that decay continuously, where this formula does come about. Like populations are said to grow continuously. Radioactive elements are said to decay continuously. So this formula will have real life applications, a lot of them. Money is not one of them. But because money is for students like so easily understood, that they associate this with money growing continuously. That's why the formula exists. Let's talk about what these variables stand for. So A is the final amount when all is said and done. You put money in the bank, you get an interest rate, it grows for however many years, and then boom, that's how much money I have now. P is principal. That's your starting amount. When you guys get jobs, you should put money into a retirement account like day one, a large percent.
Advice.
Well,
Explain to me what a 401k is. Yeah,
it's a retirement account. It's a retirement account.
Which
So
one is better, 401k or a Roth IRA?
Yes.
they'll say a Roth because your Roth is pre-taxed. So you get taxed now on littler dollar amounts. Then when you retire and you go to pull that money out, like whatever you have, it's not taxed. Like whatever's in there, you get that money. Whereas if you don't do a Roth IRA, now you're not getting taxed, but then you have a lot of money, and now the government you'll look and be like, you have $1 million, and then the government's like, no, and then they tax it then. So now some companies, you don't get a choice. Some will do like a 401k match where a company will say, we'll match what you put in up to like 5%. So you always want to, whatever your company will match, you at least want to put in that amount because they're giving you free money for when you retire.
Oh, okay.
The advice people typically give is you should almost always, as soon as you get a career and start working, start putting 10% of your paycheck in day one. That way you never miss it. It's hard, let's say like years go by and you haven't done that. And then you're like, well, first of all, you've missed out on a whole lot of free interest and that you should get. And two, now it's going to be harder to lose money than you see it. So the reason I'm talking about this, we just met with our financial advisor over break and got a lot of really good news. Like we found out we could both retire at 55 if we wanted to, because we've both been pumping money. We feel like we're broke now, but that's because we've been putting so much into our retirement that it's like, whoa, I didn't realize that. So
I mean, if you never get old, you never have to retire, so.
Mortal me, but-
why would I not want to get old?
Being old is
Oh,
My dad's the best. He's like 65. He's awesome. Anyway, okay. Oh, I wasn't done with this formula. So R is interest rate, and that's as a decimal. No difference there. If your interest rate is 5%, then you'd put 0.05. T is time.
Yeah.
In years.
What's E?
Oh, gosh, you guys are just falling hook, line, and sinker into my web of questioning today. The question was, what is E? Anybody know?
I don't want.
Eagle and Bernie, like Bert and Ernie.
It's gonna be something to do with an exponent.
What? So I know you guys at home aren't in here, but maybe you've seen this. But you guys in here, I want you to turn around and look at that green poster in the back.
I don't like that number.
The green poster, and you guys can look at this when you're in here Thursday. It says, surprise, the letter E is also a number. And it has this guy writing this decimal going on forever, and he looks exhausted, even though he's only written like 40 numbers. That shouldn't be that exhausting. But the point is, it's a number like pi that will go on forever. So it's an irrational number. Just like you guys have learned about pi since you were in, what, 4th grade or something? E is like pi. It's an irrational number. It's a number that will always be, there is an E button, and we're going to use it. But E is always a number. E will never change. E is 2.718, and then it goes on forever. You'll have an E button. I'll show you here in a second when we have to use it. So you never actually have to know what E is, like the number.
No E memorization contest like there was for pi.
No, that'd be cool. This is all I know. I only know 2.718. But the thing is, just like in your calculator, you never type 3.14. Like there's a pi button that you use or should use. You'll use the E button on your calculator. So you never actually have to know this number, but it's 2.718. A lot of students will say, what is it? Where does it come from? It's hard to explain without getting into calculus, but it's basically a number that scientists and mathematicians, when they started studying things that grow continuously or decay continuously, this number just always kept showing up. It's like a magical number in math that they kind of show you what it means in the poster, and maybe we can get into it another time. But anytime things grow or decay continuously, this number shows up. And that's why it's in the compounding continuously formula. But the good news is your calculator will just do it. So let's do the example. A total of $12,000 is invested. So you put $12,000 in a bank at an annual interest rate of 2.5%. Find the balance, meaning find how much you have after 5 years if it's compounded continuously. Since I see the word continuously, the first thing I have to do is focus on that word, because that tells me that I have to use the PERT formula. If the problem said it compounds monthly, we would have to use the first one. So you don't get to choose. You have to know which one to use. So we're going to use PERT. We're looking for the final amount. So we're looking for A. We're putting in $12,000. We just write E. We'll talk about how we deal with that in a second. And then to the R times T. So 2.5% is 0.025. And then T is 5 years. And essentially, since everything on the right side is a number, we can plug that entire thing in our calculator. We're like not solving for anything. We're just doing this in our calculator. So I'm going to show you guys how I do this in the calculator, but you guys can do this a different way. The first thing I want to do is figure out what E to that exponent is. So yes, in your calculator, there is an E button right above the division sign. If you look at, I'll highlight this for you guys at home too. Honestly, I have never once used this E button above the division sign right here. Anytime E is being used, it's being raised to a power. And so there's a different button right here above ln on the left side that says e to the x. It's not wrong to use that e button, but because it's always raised to a power, I just always use this one instead. If I push second ln, then it gives me e to that exponent right here. And then I'm going to do, so that exponent is 0.025 times 5. I like to push enter at that point. And then I'm going to multiply that number by 12,000. So 12,000 is the last thing you'll do. And after 5 years, you'll have $13,597.
That did not hurt.
Is there any reason why?
I mean, you gained $1,600 in 5 years. It's not bad.
But it says continue, so yeah, I figured it.
Yeah. What'd you say, Brenna?
Is there any reason we can't just plug it in as like one long string?
No, you could plug it in exactly as you see it. There we go. Questions? So your homework will be over like all three things. The first thing you're gonna have to do is get your bases the same. There's a couple graphs and then a few interest problems. So, all right, you guys at home, you are free to go. I'll see you guys on Thursday. We'll talk about logarithms. Peace out. Let's see. Stop recording.